morning. This is Jerry Tuttle, and I'd like to talk about what do data analysts do. Today, companies like Amazon, Netflix, and even your local supermarket collect enormous amounts of information, and they use it to predict what you might want next. Data analysts are the people who help businesses make sense of all that information. In this talk, we'll look at some real and make-believe examples of how data is used, and we'll explore some of the techniques behind the scenes. There's a little math, but not much. The focus is on ideas, not formulas. This isn't a talk about artificial intelligence, but many of the methods we'll discuss are the building blocks that modern AI relies on. Why does this topic matter? Companies use data to understand us and to predict what we might want to buy next. Data analysts turn raw information into useful insights. This talk is about ideas, not math. Hopefully the examples will feel familiar. Have you heard the Google pizza joke? So Mr. Jones calls and says, "Hello, is this Gordon's Pizza?" And the voice on the other end says, "No, sir, it's Google's Pizza." "So it's a wrong number? Sorry." "No, sir, Google bought it." "Okay, take my order, please." "Well, sir, you want the usual?" "The usual? You know me?" "Well, according to our caller ID data sheet, in the last 12 times you ordered pizza with 3 cheeses, sausage, and thick crust." "Oh, okay, that's it." "May I suggest to you this time ricotta, arugula with dry tomato?" "What? I hate vegetables." Sorry, your cholesterol is not good, sir." "How do you know?" "We cross-checked your phone number with your name, and we have the results of the blood tests for the last 7 years." "Okay, but I don't want that pizza. I already take medicine." Excuse me, but you have not taken the medicine regularly. From our commercial database, 4 months ago, you only purchased a box with 30 cholesterol tablets at Drug Sale Network." "I bought more from another drugstore." "It's not showing on your credit card statement." "I paid in cash." "But you did not withdraw that much cash according to your bank statement." "I have other sources of cash." "That's not showing on your last tax return unless you bought them from undeclared income sources." "What the hell?" "I'm sorry, sir. We only use such information with the intention of helping you." Enough. I'm sick of Google, Facebook, Twitter, and WhatsApp. I'm going to an island without internet, cable TV, where there is no cell phone line and no one to watch me or spy on me. "I understand, sir, but you need to renew your passport first, as it expired 5 weeks ago." So what does Google really know about us? Well, here are some of the apps that Google has, and they probably know quite a bit about us. But this isn't about fear, it's about understanding. Companies collect data to personalize services. Someone has to make sense of all this information, and that's the data analyst. So here are some famous data examples. Perhaps you've heard of the Target story of the teenage girl who got baby coupons in the mail. This is because her buying patterns of unscented lotion, vitamins, nutritional supplements suggested she was pregnant before she told her father. And the story is the father was so incensed that he stormed the store and demanded to speak to the manager. But at some point, his daughter admitted, "Yes, Dad, I really am pregnant." Another famous data analysis example is the book and the movie Moneyball, where the Oakland A's use new kinds of baseball metrics, such as on-base percentage, to build a team of undervalued players. Moneyball is an example where data analysis supplements, but does not replace, human judgment. So what exactly is data science? Data science has been described as the intersection of math, computer science, and domain knowledge. It's also been described as more math than most computer science people want to use, and more computer programming than most math people want to use. But then comes the domain knowledge piece. The domain knowledge is understanding the subject of the data. For example, if the analysis is about insurance, the analyst needs to have some understanding of insurance. And I had a personal example of this. An analyst brought an insurance analysis to me, and it was clear that that analyst did not understand the insurance business, and I did not take her analysis very seriously. Data science, though, however, is broader than data analysis. Data analysis examines data to find patterns and answer specific questions. Data science builds predictive models and more advanced tools. The items are fuzzy and often used interchangeably. Data science is broader and more technical, but today we're focusing on the practical work that analysts do. So what do data analysts actually do? Data analysts gather data, clean it, query it, create visualizations, interpret the data, and communicate insights. Some days it's 4 hours of programming and 4 hours of meetings. Let's look at what cleaning the data really means. Cleaning often takes more time than programming. And as a quick example, suppose a data set contains a column and some of the entries are uh, capital N, capital Y for New York, capital N period, capital Y period, and New York spelled out. Those all mean the same thing, but they need to be uh, put in a single format for the analysis to make sense. Next, querying a database. Querying is asking the database to find some specific data. Uh, I did this one in response to a trivia question where I asked, where I was interested in who are the top three Yankee leaders in a single season in doubles. And I queried the database to answer this question. Next, designing a dashboard. This is an example of a data dashboard to show real-time data from multiple sources at a glance. If I were a restaurant manager, I think I'd want to monitor things like average time to be seated, average time to be served, kitchen backlog, inventory levels, etc. And if I had a a dashboard like this accessible to me with real-time data that was changing every moment, this would help me track real-time activity and spot problems quickly. Here are some of the methods we'll explore today. These are all somewhat mathematical, but we're discussing ideas, not math. And some of these are the building blocks behind many AI systems. Let's start with the simplest and most familiar, regression. Regression is predicting numbers by drawing a line through data points. For example, if bigger homes tend to cost more, we can try to estimate price from size. We're not trying to be perfect, just reasonably close. So let's look at predicting house prices in a little more detail. So here we're starting with a single variable, square feet, to predict house price. We draw the best fitting straight line and we get a conclusion like each additional square foot is expected to increase price $196. We'd measure accuracy of this by how well the straight line fits the data. So that's one variable. If we added more variables, such as location, age, condition, etc., this usually improves accuracy of the prediction. And the goal is to estimate a reasonable price, not an exact price. Next, let's look at predicting, instead of numbers, categories. Classification is predicting the category of the data. This time we're sorting things into buckets. Is that animal a dog or a cat? Will the loan default or not? We again graph the data, but this time we try to separate the data into categories. And the goal is to estimate a probability, not certainty. Now let's look at a real example predicting loan default in a little more detail. So again, we start with a single variable, and this time we're starting with the ratio of debt to income. And so what this is all monthly recurring debt payments divided by gross income. And we'd like to use this ratio to predict the probability that a loan will default. An important math concept is odds. How likely is something compared to not happening? I'm sorry, how likely something is likely to happen compared to it not happening? So for example, if the probability is 75% happening, it's 1 minus 75% or 25% of not happening. And then the ratio is 75 divided by 25 or 3 to 1. We're still drawing a best line, although it is a curved line called logistic regression. And this time we get a conclusion like each additional percent of debt to income increases the odds by 0.015. It's actually the logarithm of the odds, but let's ignore the logarithm part. Adding more variables usually improves the accuracy. Now let's look at a method based on yes or no questions called decision trees. This is a series of simple yes or no questions. Do you remember that game 20 questions where as you you ask a question and try to narrow things down step by step? I used to play this with my kids. So for example, suppose I'm thinking of a president. A good first question might be something like, did he serve during the 20th century? That would divide the group of potential answers, not quite 50-50, but quite a bit. A bad first question might be, did he resign while in office? Because if I got that right, that's great. But if not, I've only eliminated one person. A visual decision tree is intuitive and transparent. So let's look at a small example tree. Back to predicting loan default. Each tree branch represents a rule. Simple questions lead to simple decisions, and each tree branch ends with probability of prediction. So we start with the first question on top, and then we follow the branches either left or right based on the answer, and we end with a prediction or a category. In this case, it's based on the answers to these questions. Either there's a low risk of default, a medium risk of default, or a high risk of default. Next, let's look at clustering, grouping similar people or items. So imagine sorting a box of mixed buttons without being told how to sort them. Maybe you'd sort them by size, by color, by material, by number of holes. And the question would be, well, how many groups should you sort them into? So clustering finds similar items. There's no particular label. The algorithm discovers the patterns on its own. The simplest clustering method is called k-means. And we want to discover patterns. We want the items in the same cluster to be more similar to each other than the items in other clusters. Now let's look at a real example of this, customer segmentation. Companies use clustering to understand patterns, not individuals. So a store may want to group customers by behavior, such as frequent shoppers, bargain hunters, and seasonal buyers. And once it has this information, uh, it might market them differently, send them different coupons and so on, uh, give them personalized offers and improved service. And again, this is about grouping behavior, not judging people. Next, let's look at neural networks, the engine behind modern AI. Neural networks are inspired by how the brain works. So, for example, suppose I'm trying to remember the last name of an old girlfriend. I think its the name is a color, but I just can't remember it. I know lots of names of colors, and I'm thinking about these colors. I also know a lot of logos of soda brands and their colors. Now there's a soda brand I'm thinking about. They don't make anymore with an unusual soda logo. Now I remember her name. So in this example, I had different layers of information. Each layer transforms and improves the input before it, before passing it forward. And all the layers combined got me the answer to my question. Neural networks find complex patterns and can detect subtle patterns that other methods might miss. So here is a network for spam detection. Each node is like a mini calculator. Each hidden node is like a little assistant looking for a specific pattern. So the input layer might be information on misspelling, sender reputation, keywords, time of day, etc. The hidden layers combine these inputs to detect patterns, and together they help the network decide whether an email is spam or not. And the network learns by adjusting the strength of its connections. Now let's look at how we analyze text. Text isn't just words, it's data also. Anytime we write a review, send feedback, or post online, companies can analyze the language to understand what people like or dislike. Text analysis can measure sentiment, meaning whether the tone is positive, negative, or neutral. It can compare writing styles, for example, to see whether two documents were written by the same person. For example, someone did an analysis asking which tweets did President Trump write and which tweets did his staff write. Computers can read text in bulk and look for patterns that would be impossible for a person to notice manually. Another example of how text analysis is used is in law enforcement. Law enforcement agencies use text analysis to scan public social media posts for certain patterns, for example, violent language or threatening phrases. However, there are many false alarms. For example, a word like hit, target, or execute may be harmless or perhaps not. Here's an example of a piece of text. If we can't secure the supplies by tomorrow, there will be serious trouble. We must address this. We must secure the package. That certainly sounds suspicious, and that could be a harmful text, but really a human investigator should investigate further and decide whether it's serious or not. A lot of TV shows exaggerate the accuracy of this. And I've observed many cop TV shows have a quirky data person This is Penelope Garcia from Criminal Minds. Next, let's look at how we analyze images. My dog can surely distinguish another dog from his enemy, a cat. Images are data too. Images can be turned into numbers. Every pixel has a brightness and a color value, and computers can analyze those patterns to recognize what's in a picture. And this is used in many places, such as cars detecting pedestrians, doctors spotting early signs of disease, phones unlocking with your face, insurance companies checking for fraudulent photos. This requires, though, a large amount of data to train the model. Here's how computers could map a face. A face has many key points: eyes, nose, etc., specific corners of the eyes, the tip of the nose, the edges of the lips, etc. And by measuring the distances and angles between these points, the computer creates a kind of signature for the face. This is not perfect, and things like aging, facial hair, glasses, lighting, and makeup can change the measurements, but it's often good enough to match a live face to a stored photo. These measurements are then fed into a neural network, which decides whether two faces are likely to be the same person. So now, what is artificial intelligence? Artificial intelligence refers to computer systems that can perform tasks we usually associate with human intelligence, things like learning, reasoning, or making decisions. You interact with AI every day. Search engines predict what you're typing, virtual assistants answer questions, apps recognize your voice or your face. But AI uses many of the techniques we've already discussed, in particular neural networks, text analysis, image analysis, and pattern recognition. But it's important to remember AI is not magic. It can be wrong, it can be biased, it doesn't understand morality or common sense the way people do. Some final thoughts. Many of the methods we've talked about, clustering, facial recognition, even some neural networks, rely on measuring the distance between points. And those distances come from the same Pythagorean theorem we learned many years ago in school. Students often ask, why do we have to learn this stuff? We'll never use it. Well, here it is, quietly powering a surprising amount of modern technology. It's a nice reminder that simple math can have real-world impact. So thank you for listening to this. I hope I gave you a clearer picture of what data analysts do and how these techniques show up in everyday life, from movie recommendations to medical imaging to the apps we use every day. Thank you. Have a nice day.